Hi everyone, and welcome to the Laser channel where we learn, create, and share. My name is Greg. This is the fourth video in the series featuring the Onyx laser machine by Monport. In this video, I'm going to show you how to connect the rotary attachment in 3 easy steps. Thanks for joining me again for another video on the Laser channel. I have this video designed in 3 different steps to get you up and running as quickly as possible using the rotary unit. The first step is going to be installing the rotary unit. Step number 2 is going to be the setup and calibration with Lightburn software. And step number 3, equally important, is how to uninstall the rotary unit from the machine, making the Onyx laser machine ready to do flat work. In just a minute, I'm going to cover the materials I'll be using in this video. Before that though, I do encourage you, the first time you watch through this video, please watch it through its entirety. If you start skipping around through the video, you will skip some very important steps, and there's a very specific steps for installing and uninstalling the rotary unit from the Onyx laser machine. The materials that I'll be using in this video are primarily for the calibration of the rotary unit. I will be using a glass jar. This glass jar, it cannot exceed the diameter of 2.75 inches. I'll be using some blue painter's tape to wrap around the glass jar when I do some test engravings. This way I can peel that blue painter's tape off as many times as I need to while I'm doing my test engravings. During the calibration process, I will need to know the diameter of my jar. For this, I have a measuring device, and we're going to want to measure this as precisely as possible to get the best calibration. Lastly, I have a zip tie. This is not a part of the calibration, but I think it's just as important. I have the rotary cable installed. The first thing that I notice is whenever this cable moves around, it puts all the stress right here at the connector, and this is going to cause the wires to freeze in a short amount of time. This is where I'm using the zip tie, and I'm going to put this around and make sure that that wire doesn't flex just at the connector. This looks much better. This step is going to be done with power off on the Onyx machine. I'll start by removing the debris tray, the honeycomb. Next, there's an interlock switch back here in the corner. There's a little slide in front of it, and we need to slide that over so that this switch is closed. This switch is normally closed when the debris tray is pushed all the way into the machine. However, with the rotary unit, this tray does need to be removed. Next, we're going to see that there's a huge hole cut in the bottom of the machine so that it can receive the rotary unit. This is cut all the way through so that you can see the workbench, and as a precaution to make sure I don't accidentally laser my table, I am going to put down a metal plate. This plate is also included with the Onyx machine. The metal plate is actually in the bottom of the debris tray, and it's a nice black aluminum sheet metal. I'm going to slide that underneath, covering up the hole underneath the machine. I'm going to place some blue painter's tape in each of the corners. The next couple of steps are very straightforward of placing the rotary unit inside of the machine. I like to push mine all the way against the left side of the opening here. This way it will automatically be squared up against the rest of the machine. I'll place the cable underneath the gantry. I'll gently slide the gantry forward. Along the back of the machine, here is the connector for the rotary. It does have a black rubber boot. I'll remove that, and I'm ready to plug the connector in. The connector does have a key marking. On mine, I have the key marker facing towards the right when I plug it in. The last thing I need to do is there is a switch here between standard and rotary. I can flip this to rotary. The rotary unit is installed, and I'm now ready to power the machine up. There's a couple important steps here that are going to happen. Normally on power up, the X and Y, Z coordinates home in this back corner. With the rotary installed, the X-axis will continue to home in this corner. It's the Y-axis that will not be able to home because this axis has now been replaced by the rotary unit, and the rotary unit does not have rotary switches. We'll see what we do to get the machine set up with power on. I'll turn power on and we'll see how to get the homing sequence satisfied on the machine. We'll see this homes normally as usual. We're going to see that the rotary is turning, and that's because the machine is thinking that this gantry crane is going to go to the back corner there, thinking that it will hit the limit switches. I like to wait for about 30 seconds and then the rotary will slow down and it will be turning in the opposite direction. This is where I will gently push this gantry all the way back to make that homing switch. I'll hear it click. These will start rotating in the opposite direction, and I will make the switch in the back here one more time. And now the machine is ready, and we'll head over to Lightburn software. The first thing that I'll need to do is activate the rotary attachment within the Lightburn software. For that, I look for a toggle switch in this area. My machine doesn't show that. To make that show up, I'll navigate to Edit, Settings, and there's a little checkbox here, Show Rotary Enable on Main Menu. I'll hit that, OK, and here the rotary switch now appears. I'll turn that on, and I'll navigate to the top of the screen to the Rotary Setup button. The rotary setup. This is something that will only need to be done once. Let's take a look at what I have on this screen. The rotary type is going to be roller. I have it already enabled. The rotary axis is going to be set to Y-axis. Steps per rotation. This is what I'm going to use to calibrate the rotary unit. The roller diameter. I took a very precise diameter reading of this roller. That's on the machine, and on my machine, I got 0.85 inches. Down below is the calculator for the object diameter and the circumference. This is where I used a ruler and I very precisely measured the diameter of this jar, making note that the sides of my jar are perfectly flat. There's no taper to them. I measured very precisely 2.75 inches, and that is what I entered right here. And Lightburn automatically gave me the circumference of 8.63 inches. When we do the calibration, I only need to go out about 2 or 3 decimal places. I'm going to loop back to steps per rotation. When you first open this screen, you're going to see a very large number, something like 10,000. And this number is far too wide. If I sent a graphic out to the rotary unit, that graphic is going to be really stretched out. During the calibration, I found that I needed a number of 1,600 to get the proportions showing up correctly. To ensure that the proportions are correctly, what I'm going to do is draw a box around the circumference of this jar, and I want the ends of that box to just meet up. I don't want them overlapping, and I don't want them coming up short. When they meet up perfectly, I will know when I draw a graphic in Lightburn software and I send it out to the rotary unit, the proportions and distances will be correct. I'll show you what I mean. As mentioned, I have my jar diameter already entered in, and I'm going to copy the circumference here. I'm going to copy that. I can click OK out of the screen. And I'm going to draw a calibration rectangle here. I'm going to make sure that my padlock is unlocked so that I can independently adjust the width and the height. For the height, I'm going to paste that circumference number in, and for the width, I only need about 1/10 of an inch. What I'm going to do is engrave this box on the jar, and once again, what I'm looking for is the 2 ends of that circumference box to just meet up on this jar. I'm now ready to place the jar in the rotary unit and align the laser head up to the top center line of the jar and double check the focus. In Lightburn software, I've jogged the laser head over 8 inches to put it somewhat over the area of the rotary unit. I can place my glass jar in, and to check the alignment of the laser head up to the jar, I'm going to remove the protective guard. And I'll just by hand move the laser head to a spot where I like. This looks like it's directly at the highest point of the jar, and I can make any adjustments here that I like. When I check the focus, I have perfect focus with a jar that is 2.75 inches in diameter. This mechanism is in the home position. This means that 2.75 inches is the largest diameter that we can place in the rotary unit before we move the machine up to place larger objects in the rotary unit. I'm going to show you how I would do that at the end of the video. Back in Lightburn software, we're going to see across the top of the screen, I've got this little crosshairs, and this is the actual position of the laser module on the x-axis. And I am going to take my calibration box here and move it right up to that because I am still in absolute coordinates. Navigating to cuts and layers, the settings that I'm using for this calibration box is I just want to draw the outline of it, so I'm not engraving, I'm just doing line. I have the speed set at 75 millimeters per second with a max power of 18%, minimum power at 17%. That's just enough power to mark the tape. I'm all set to do my first calibration check. I've marked out 2 black lines, and in between is the ends of my calibration box meeting up, and to me that looks absolutely perfect. My circumference calibration on the glass jar looks perfect. I do realize that there are variations on machines and rotary units. Because of this, I'm going to again show you the number that you would change to make sure that your calibration box lines up perfectly. And it's going to be this steps per rotation. This is the number that I use to either get the box to draw longer or shorter. There's one more step in the calibration process, and that is to check to see if images going out to the rotary unit need to be mirrored. For this, I am going to lightly engrave the number 2 on the jar. Inside Lightburn, I'll grab the text tool and type in the number 2. And I am going to rotate this number 2 so that the top of the number 2 is facing towards the right or the opening of the jar. I no longer need this calibration box, and I can delete that out. And I'm going to move this number 2 up near the line up here. Here's the number 2. It is facing up towards the top of the jar and facing the correct direction. I don't have to mirror my images going out to the rotary unit. This concludes step number 2 of calibrating the rotary unit within the Lightburn software. Before I move on to step number 3, I did mention that the largest diameter when the machine and the rotary are on the same work surface, that diameter is 2.75 inches. Can this machine engrave larger diameters? Absolutely yes. The only thing that I would need to do is I need to raise the entire machine up, and the easiest way that I can think to do this is to use soup cans or tuna cans. That might sound a little bit odd, but I've used it on the past on other machines, and it's a very nice and quick and convenient way to raise the machine up. We are now ready to proceed on to step number 3, where I reconfigure the machine back to doing flat work. This might seem pretty trivial. However, if I skip a couple key steps here, the next time I power up the machine, it may think that it's still in rotary mode, even though I'm trying to do flat work, and things just aren't going to run right. The first thing that I'll do before powering down the Onyx machine is to go back to Lightburn software and to turn off the rotary enable. The rotary enable is turned off, and now I can turn the power off to the machine. I'll move the gantry forward to allow easier access to get back to the connector from the rotary. I'll disconnect that and make sure it's tucked out of the way. I'll take the switch from rotary position, move it back to standard. I'll move the gantry back towards the back of the frame of the machine, and I can remove the rotary. I'll move the slider back out of the way so that this switch is now active when the debris tray is placed in the machine. I can remove the piece of sheet metal I placed underneath the machine that came from the debris tray. The rest here is pretty straightforward and easy, replacing the honeycomb, replacing the debris tray with that piece of sheet metal. Thanks for joining me in this video. I hope that you'll join me in future videos featuring the Onyx laser machine by Monport. Don't forget to like this video, subscribe to the channel, and ring that notification bell. This way you'll know right away the next time a video comes out on the Onyx laser machine. Until next time, learn, create, and share.